Hi good people, Titus here for another Unreal Engine tutorial, and in this video I'll show you how to create a simple dash mechanic for the third person template. Let's not waste any time and jump right into it. Alright, starting off we're going to go into our content folder and let's find the third person template, and under input we're going to have access to our input mapping context and our actions. Let's go into the actions folder and create a new action. This will be input action. We'll call it I_dash. We can then go back to our input folder, open up the IMC, expand out the mappings, and we just have to hit the plus sign to add our new action, which is the dash. If we expand that out, we have to assign a key binding or a mouse binding. I'm actually going to use a mouse, and I'm going to do mouse left click, so the left mouse button here, and then we'll save, and that's pretty much it for the controller setup. Now let's go back to our actual blueprints folder for the third person, open that up, and let's find a blank space, and we can right click and do I_dash, and you'll see the enhanced action event, so we can call into that. And then it's pretty straightforward. We can actually drag out the character movement component to get a reference. And then you're basically just going to be setting a max walk speed. From the walk speed, you'll want to set max acceleration. And then we're also going to want to change the braking friction. So we could probably do that in the actual character movement directly, but there might be instances where you want to flip it back. So our default walk speed I think is 500. Yeah, 500 right here. So let's do something crazy like maybe 5,000. Our max acceleration, if we want to hit that point quickly, let's just make it the same. And then for the braking friction, I think 1,000 or 2,000 usually works pretty good. And then right off the triggered, we can basically drag in like that, and that'll handle basically when we start the dash to increase the movement. But let's just go ahead and duplicate these nodes because we need to return it. So the default walk speed was 500. The default acceleration I believe is 1,000. No, 1,500. So 1,500 there. And default braking friction, I'm actually just going to delete that because I'm actually not going to set that for now. And then we'll hook in the target inputs here. We'll have to expand out the dash so we can see the completed pin, and then we'll hook that into the completed section there. Now if we compile and play this, it should work for the most part. It's just going to look a little weird. So you can see it doesn't look too good, but we're definitely moving faster. We're dashing. So to make it look a little bit better, you'd want to increase the play rate of your actual animation. In our case, we're using the SKM Quinn mannequin, which goes off Manny. So it uses an animation blueprint basically. So if you're driving the animation states directly on your graph, you just expose the play rate as a pin and then just set it in your event graph. Because I'm using the template, we're going to have to come into the actual starter content, and there should be, actually I think it's going to be under characters. So under the characters there's a mannequins folder, and then we have an animation folder, and then you can see the animation blueprint for Manny and Quinn. Manny's actually the parent, so we can just make the edits directly on Manny himself. And you'll be brought to the event graph, but what you want to go into is the actual animation graph. And here's the state machine that they have set up for this default character. Under local motion is where you'll find the walk run animation. And then if we go into that, you can see they're doing it with a blend space, and they're using a ground speed variable. If you click on the blend space and scroll down, you'll see the play rate, if you hit the bindings, there's an option to expose this as a pin. So now you have access to actually directly affect it. Now your play rate should be 1 for the normal animation cycle from wherever you made it from, whether it's Blender, Maya, or whatever. If you double or triple, then the play rate's going to be a lot faster. So we need a way to basically double or triple this. Currently they're getting a reference to the ground speed, which is currently cycling between 500 and 5,000. So on the regular state, we need to somehow turn 500 into 1, so we get a play rate of 1. So we can do that by coming off and maybe doing a divide, and then you can divide by 500, which would then give us 1, and that'll give us our standard play rate. The problem with this though is if we are walking at 5,000 and you divide that by 500, you're going to get 10, which is a bit too fast. So I guess an easy way to do it is you can probably just come into a clamp, and you can do a clamp float. Your min value will be 1 and your max value will be 2 or maybe 3, depending on how fast you want your play rate to go. And that's just a quick and dirty way to do it. You can actually, honestly, probably just do it off like a Boolean check, and then in the event graph, you can do like a cast to the actual character, and you can maybe expose a variable over here. And so there's a lot of different ways to basically do this logic, but this is just a kind of like a quick and dirty way to do it. But if we compile and play that, you'll notice if we do our normal run, it looks fine. And then when we dash, you can see the play rate increases to 3, so it looks a little bit better. But there is an issue with it. We shouldn't be able to dash while we're in the air. You can see that here. If I jump and then dash, I can actually increase my movement speed, which is a bit weird. So to get around that, we can come back into the blueprint character, and then we'll just drag into a branch, and then you can just do right click is falling. It'll make a reference to the character movement automatically. And for this one, I'm coming off the true pin, so I want to do a not Boolean. So basically I'm checking if the character is not falling. If they're not falling, then go ahead and increase the movement speed. If they are falling, do nothing. And then that should make it where I can't increase my movement speed while I'm jumping, but I can jump into a fast speed, so that'll still work. And then it gives you a little bit of error control too, so I mean, depending on the mechanic you're trying to implement, you know, you might want that or you might not. And then with that dash mechanic implemented, if you wanted to maybe add a little extra pizzazz to your character, you can add your favorite Niagara system, and then drag that into the actual scene. And we'll maybe pull this back a bit. And then we can drag this into a set active. And this one will be active, this one will not. So on the completed, we'll drag into here. And on the true, we'll drag into here. And then if we go back to the viewport, we can select our Niagara system and set auto activate to off, compile and save. And now you have a pretty cool Niagara system to go along with your dash mechanic. And Niagara gives you a lot of flexibility on, you know, the different art style that you want to go for, or whatever you want to do there. Which is pretty fun. All right, people. We'll cut it here, but I hope you found some informative value in this topic. But as always, thanks for watching, consider subscribing, and see you on the next one.